Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Jack Harding, the CEO of eSilicon. Jack, we've got lots of things that are changing in the industry, but where are you seeing the real pain right now, and how is that affecting the industry?
So Ed, as you mentioned, this is the semiconductor industry, and there's lots of pain all over the place. But I thought today we'd just comment on the pain du jour, which I think is the NRE situation. You know, at the current 28 nanometer process technology, when we develop an ASIC for somebody, and this is true for anyone making these chips, between the labor for the layout, the mask set, and some third-party IP, you're probably talking $7 to $9 million of expense, and that's just going to get greater from here. So that's a good starting point if you want to talk about a problem.
So what does that actually mean in terms of how do people knock that down? We've been talking about NRE for many years, and it's been getting worse and worse. But NRE is only a very small piece of what it costs to develop a chip, but it's also one of the critical pieces that people do have control over. So how do you reduce that?
Well, first of all, there's an issue of relative dollars versus absolute dollars. I think historically we said, yeah, the percent of the NRE expense was going up, but the absolute dollars of now are hitting, 7, 9, 10 million bucks, and that's real dough. So I think one of the things we have to look at is how to streamline that. But before we do, it's like the old adage, it's not whether you fly first class or business class or economy, it's whether or not you get on the plane. And I think that's what most of the developers of complex chips are deciding now. Do we even make that chip at that NRE? Because if you spend that kind of money and it does not go to production or does not achieve the production you expected, well, obviously you have a return on investment problem, which you will add up very quickly, and you can only afford so many of those mistakes. So I think the first point before we decide how to fix it is we just have to recognize a lot of people are thinking twice before they even pull the trigger.
Are we getting to the point now where when we move from node to node, the NRE is going to be jumping more than in the past? Is it a fairly consistent run? So when we went from 40 to 28, is it the same as going from 28 to 20 and then 20 to 16, 14 with FinFETs?
Well, actually, that's a great question. Let's just start with the physical design labor. At 40 nanometer, the average chip took about 4,000 hours. At 28 nanometer, we see 15 to 25,000 hours. And we recently just looked at a couple 20 nanometer chips that were between 75 and 90,000 hours of labor just to do the layout and the DFT. So, take those hours and multiply that by whatever you want, $100, $150 an hour, you're talking significant expense. And we all know that the mask sets are, increase in expense, maybe, 30, 40% for each process node. We'll see that again, which leaves the remaining 1/3 of the equation, which is third-party IP. Last time I checked, the IP was not getting cheaper for each successive node. So I think we can expect to see a geometric or semi-geometric growth in the expense, where at 28 nanometer, we're talking, call it 8 or 9 million. At 20, you're probably talking 12 to 14. And above 15 at 14, 16 nanometer FinFET. So it's a real problem. It's getting worse. And as I mentioned, it's not just a percentage change that's matter. It's the absolute dollars associated with deciding to build that particular product.
So what we're also addressing here is the risk of failure has gone significantly higher. If you get something wrong, it is much harder to deal with and recover from than if you got it right the first time.
Well, yeah, that's really the essential point. The table stakes are going through the roof. And so if you think about it too, as you build denser and denser parts, based on the process technology and eventually based on 450 millimeter wafers, how many chips is a company going to make in a year? The guy who made 10 chips, a couple, 3 years ago might make 1 or 2 now and 1 in the future. So there's, in addition to the cost and the associated risk of getting it right, you have the added variable of losing the recipe to get it done. And that's why we're seeing a lot of our clients and prospects telling us that they may not be doing any layout in the future because they need to deploy those resources in software development, IP development of different types, algorithms, whatever, but they're not going to hand over a $15 million NRE task to a group of guys who haven't made a chip for 18 months at a process node they've never seen before using IP and tools that are brand new. It's not going to happen. And so we're going to see a fundamental shift into the outsourcing of the back-end design, except for the very, very largest companies who can still make enough to keep the recipe.
Clearly what you're talking about is an inflection point. Have we ever gotten to an inflection point of this magnitude in the past?
You know, I hearken back, in 1984, I went to the Johns Hopkins Applied Physics Lab to hear a presentation about sub-micron technology. And one of the speakers, who you know by the way, stood up and said, there will never be any chip developments below a micron. It's just impossibly difficult. And so for the last 20 years, we've always said it's going to be harder and different this time. And I know I have high confidence on the technology side. I think we can consistently get it done. But what we haven't seen is the price tag associated with getting into the game. You know, if you make a part for $1 million NRE and you sell some or you don't, it's not life altering. However, if you spend $10, $15 million on that same NRE and that chip doesn't go to production, there is no amount of financial maneuver or technical maneuver or whatever that you can to try to cover up or mask the fact that you just spent a fortune and got nothing back for it. And a lot of executives are not going to make that jump, and it's just too much risk. So yeah, we are at an inflection point, and I think it's going to precipitate other go-to-market strategies that we've discussed in the past, such as 2.5D or even other technologies that are on the horizon. But people are going to think twice before going to the next process. And I should point out too, if you just look at some of the data from some of the analysis companies, DataQuest, for example, I mean, they've got the number of design starts dropping fairly precipitously over the next several years, and that's, I think, reflective of some of the dynamics we're discussing today.
So most of the progress of what we've done in this industry has been incremental steps. Are we getting to the point now where people are rethinking, is it just an incremental step, or do we have to rethink how the pieces go together? Are they even set up economically correctly within companies?
That is a good point. One of the things we've been talking about in our shop is with the advent of 2.5D technology, on one hand, you have a very, very low NRE and a lot of die level reuse, which is terrific. On the other hand, on that same solution, you've got a module that's going to take up a lot more area and just cost a lot more as a unit price. However, if you look at the amount of the printed circuit board that absorbs, you start to realize that's not such a bad deal. So to your point about business model, yeah, we're up to a big change, because right now the IC development is totally separate from the printed circuit board development. And until you get the same decision maker saying, I'll trade off a 2.5D module to absorb a whole bunch of space on my PCB, and by the way, get there for a lot less time and a lot less NRE dollars, I think we're going to struggle with that transition. And also just the magnitude of the price tag involved, I think, is going to cause us to rethink a lot of the way we do our business. I mean, a classic example already is the reducing number of semiconductor startups we see. The VCs realize they just can't get the return on an exit from a company where they've invested $200 million. Well, whatever dynamic is causing the VCs to pull out of that investment environment is going to trickle into the corporations as they make the same basic decisions. Do we build these chips for this price tag, and what are we going to get in return? So I think we're going to see a lot of changes going forward, but then again, that's what makes the industry so exciting.
Jack Harding, thank you very much for your time.
Ed Sperling, always a pleasure. I enjoyed it. Thank you.